This video is going to talk about presenting findings and how your audience is going to perceive your graphs. So the crosstabs video just took you through this crosstab for the pizza restaurant. And recall that we were interested in which area should the restaurant improve if they want to satisfy their heavy users versus their new users. Now, in that example, the usage level, so number of previous visits, is going to be the independent variable because we get to choose who we target, and we want to find out how does the area that they want to see improve depend on that. Therefore, we used row percents, and we concluded that heavy users were interested in new items, while new users were much more interested in value than decor, than new items. So the question is, how do we present these findings? Now, one thing that you want to think about whenever you're making your presentation is that there's often many ways to tell the story, and so you probably want to try a variety of these ways and then see which one is going to work best for your audience. So I've kind of done that. I've made a lot of different graphs and presentation methods to tell this story. So if we go to the next slide, let me walk you through these. The first and simplest way is probably with the table. And so here's one possible table. So let me point out a few things that you should notice about the way I presented this. So first, I've gotten rid of all the superfluous information. So on this crosstab, we don't really care about the column percents. We don't care about the joint probabilities. The second numbers are those joint probabilities. We don't really care about the counts either. So just like wind speed was irrelevant to the Space Shuttle Challenger story, the column percents are irrelevant to this story, so get rid of all that stuff. Notice the only thing I'm presenting here are the row percents, and I've given an appropriate number of accurate digits. So notice I'm only giving one decimal point to the right for these fractions. You don't need to give 8 decimal points. Just I would say 3 or 4 at the most digits is about what you want to give. The second thing to notice about this table is that I've changed the sort order. So there's nothing sacred about this order. This just happens to be the way the data were stored. So 1 was decor, 2 was taste, and therefore decor came first. Chances are your audience is going to start in the upper left and work to the right and work down the way one would normally read a page. Therefore, I want to lead with what's most important. So in this case, kind of the story is focused around heavy users being interested in new items. Therefore, I'm going to put heavy users at the top, and let's put new items in that first column. You'll see that I've sorted this in descending order of importance to the heavy user. Third, I'm giving my sample sizes. Always give your sample sizes. So sample sizes are one indication of quality. They're not the only indication of quality, but if a sample is coming from 10 of your best friends versus thousands of real customers, you want to indicate that. So you want to give the sample sizes and give some indication of where that sample came from in your graph, because it reflects on your credibility. A third thing is you want to define your terms. So heavy user is a nice term in English, so people understand that, but you really should define what you mean by that. So I have a note down here that heavy means 11 or more visits to this restaurant. All right, so this is one way that you can present your findings, but there are many other ways. So another way is to use 3 pie charts. So recall that we're conditioning on usage levels. So these are row percents. If we go back to this, we have 3 rows. The row percents all must sum to 100. Therefore, we're going to need 3 pies, one for each segment here, new, light, or heavy. The pies always add up to 100%, just as the percents in the row will add up to 100. This is not a very good graph. Now, to understand why this is not a good graph, let's go to Tufte for a second. So this is what Tufte has to say about pie charts. So a table is nearly always better than a dumb pie chart. The only worse design than a pie chart is several of them. For then, the viewer is asked to compare quantities located in spatial disarray, both within and between pies. So I think this is Tufte at his best, because in one crisp sentence, he tells you what is wrong with pie charts. So one problem with pie charts is that the viewer must compare quantities located in spatial disarray, both within and between pies. So what exactly does he mean by that? Well, the comparison that you want your audience to make is going to be, well, there's actually a couple comparisons that you're interested in. First off, what do heavy users care about? So in order to deduce what heavy users care about, the audience must compare this slice to the other slices and conclude that, okay, this slice is larger than the other slices. I think another comparison that you may want your audience to make is how important is new items to heavy users versus new users. So the viewer must compare the size of this slice to this slice. Now, in both cases, we have spatial disarray. So how big is this slice versus that slice? Well, they're kind of oriented in different directions, and it's a difficult comparison to make. Likewise with this slice versus this one. So let's read on. Given their low data density, so that means there isn't a lot of information in a pie chart. You just don't have the space to put a lot of information on there. And failure to order numbers along a visual dimension, pie charts should never be used. Now, I'm going to elaborate a lot on this failure to order numbers along a visual dimension in a minute. Let's take a look at what Cleveland has to say. Data that can be shown with pie charts can also be shown by a dot chart or a bar chart. Cleveland's going to make the exact same point that Tufte made. This means that judgments of position along a common scale, so that's we'll see what that means in a second, can be made instead of less accurate angle judgments. So the human eye has a hard time making angle judgments. You can read the rest of this. This is more Cleveland. Cleveland wrote the S+ graphics user's manual. Pie charts have severe perceptual problems. Experiments in graphical perception have shown that compared with dot plots, they convey information far less reliably. I like his last sentence though, but if you want to display some data and perceiving the information is not so important, then a pie chart's fine. You also might want to see the help page on R for pie charts. There's additional warnings about their problems. So